Well, let's start solving some more really in-depth questions. And if you look at this scenario, it says a pendulum which is 65 centimeters long. So a pendulum means that it's got a little bit of a ball on the end of it. They actually call it a bob, and it swings back and forth. But this bob is attached to a piece of string that is 65 centimeters long. So as this bob swings over to this place, notice a couple things. It's still 65 centimeters long. It hasn't changed the length of the string, so that's the same. But it also said that it swings through an angle here. This whole angle is 40 degrees. Well, wait a second. This is not a right angle triangle unless I look at half of the swing at a time. Look, I'm going to look at it half at a time. This is a right angle triangle. This obviously then is my hypotenuse. This angle here then must be half of this, which is 20 degrees. Now I can start solving something. It says calculate the distance to the nearest tenth of a centimeter between the two extreme positions of the pendulum bob. So in other words, it wants this whole distance from here to here. Well, the nice thing is these two triangles are exactly the same. So all I have to do is measure one, find the distance of one, double it, and I've got the second. That's no problem. Okay, so here we go. Eyeballs. Let's do our eyeballs. Same old, same old. Notice how that has not changed for anything we've done so far. That's got to be the most consistent thing of these podcasts. There's my 20 degrees. Eyeballs are staring over here. So in fact, I'm trying to find the opposite side. I've got the hypotenuse. Okay, SOH CAH TOA. I've got the hypotenuse. I need the opposite. That's got to be sine. So sine of this 20-degree angle, opposite is what I'm trying to find. Hypotenuse is what I've been given, which is 65 centimeters. Now I can find the opposite side simply by cross multiplying. Okay, so here we go. Clear? All right, sine of 20. Sine of 20 bracket times 65, and I've got this to 22.231, and you know what, I'm going to put down 22.231 centimeters because that in fact is this distance here. Doubling it, timesing it by 2, gives me the entire distance from here to here. So let's go into our calculator. And the reason why I used 22.231 is because I don't want this to be a rounding issue, right? So leave everything on there, round at the end. Times 2 works out to be 44.46. And remember, it's to one decimal place, so it's 44.5, right? 44.5. Let's go. 44.5 centimeters. And if I would have rounded right here, I would have gotten a completely different answer. Look, if I would have rounded here to 22.2 and then multiply that by 2, I would have got 44.4, which is not accurate. See? That's why we don't round. Okay.